Hi, my name's Gabe. For this problem, we're asked to use a graphing utility to graph the functions the absolute value of x, negative absolute value of x, and the absolute value of x times sine of x. And then we'll use the ideas behind the squeeze theorem to find the limit as x approaches 0 of the absolute value of x times sine of x. So let's go ahead and graph these three functions in the same windows. We'll let y1 be the absolute value of x, y2 be negative absolute value of x, and y3 be the absolute value of x times sine of x. Now that we have these three functions graphed, we see that the absolute value of x is the v-shaped function, negative absolute value of x is the inverted v-shaped function, and the absolute value of x times sine of x is the oscillating function which moves between the absolute value of x and negative absolute value of x. So something to note here is that the absolute value of x times sine of x is less than or equal to the absolute value of x for all values of x, and our function, the absolute value of x times sine of x, is greater than or equal to negative absolute value of x for all values of x. So that means that our function, x times sine of x, is between the absolute value of x and negative absolute value of x for all the values of x. So to use the squeeze theorem to find this limit, we'll go ahead and we can use the trace feature on our graphing utility. And if we trace along the absolute value function, we see that as the x values approach 0, the y values also approach 0. If we trace along negative absolute value of x, we see that as the x values approach 0, the y values also approach 0. And since the absolute value of x times sine of x stays between these two functions, we know that as x approaches 0, the absolute value of x times sine of x is equal to 0. Thank you.